Yeah, is the water running? Water?
Well, I see the little red dot, gentlemen. What you're looking at, if you're just joining us, members
Oh,
of the board and the hardcore supporters of the Central South Coast Longtime Astronomy and Telescope Club, the Santa Barbara Astronomical Unit. I'm Ron Herring, your host for the big hour. It's called the SBAU Astro Hour. Proud to be vice president. It's a weekly online vlog using Zoom that focuses on the latest space news and discoveries. We're in the same county as Vandenberg, and we have cutting edge cosmology, hardcore astrophysics, incredible topics coming your way this hour, and featuring some of my friends, some of the brightest, most knowledgeable people in California or the county or the whole country. Actually, I don't include myself in that, but I'm learning, I'm catching up slowly. In the meantime, our vice president will meet the rest of the club members, reading my own opening here as we get ready. 11 to noon, put it on your calendar every week. We rarely are not here. I don't think we've ever missed one. We're going on our third year. We have second Saturday of the month star parties coming up this weekend. We're at about the time of the full moon, which is probably here by now. We're going to have
Was
our
yesterday.
next meeting. What's that?
Was
Jerry?
yesterday, full moon.
Oh, is the full moon pass?
Saturday night, yeah. The
So
hunter's
give us,
moon.
we're having a give us now. Jerry Wilson, everybody, our president for 5 or 6,
Morning.
7 years, provides us with our talking points and is married to Pat Forgy. And he does a good job, and that's got to stop. Here's Chuck McPartland, just an outrageously outreachable outreach coordinator. Chuck is married to our merchandise manager, Pat McPartland, who may be changing careers with us in the new year. Chuck is also our secretary. Joining us consecutively, or what's the word I'm looking for? One right after that. Our first joiner was Tim Crawford, who was in front of the moon, the picture that he took. And you guys, I guess, Tim's not as connected with the weekly telescope workshop as he used to be, but he's definitely around. I guess Jerry runs it, but it's being moved to Thursdays, right? We'll talk
No,
about
we
that.
moved back to Tuesday.
Oh, you moved it back? Oh, I
We
didn't get that
unmoved.
message.
Turned out that Thursday caused more difficulty than Tuesday.
Well, I thought it was because what's the word I'm looking for? It
Conflict.
collided with something else going on that night.
It did, but it collided with more of them on Thursday night.
Oh, is that right? All right. Well, Tim is married to Karen, longtime supporter and member. And here is Tom Whittemore, editor of the
Morning.
Santa Barbara Astronomical Unit newsletter. Tom, and a former Westmont College science instructor, married to Maureen.
Yep.
At the bottom of the screen on my particular laptop is Bruce Murdoch. Hello, Bruce.
Hello.
Longtime supporter, ardent telescope enthusiast, president of the Santa Barbara Theater Organ Society. His wife is Bonnie. This hour, going to touch on a lot of things. A couple asteroids in the news. One of them is a real lemon. The other may have come from the moon.
On an asteroid.
And I guess we're in the gibbous section of the moon right now. We got a lot of history of the moon this hour, some close-up shots. We're going to take a look at Arcturus, the alpha star in the western sky. And for Halloween, which is tomorrow night, this is for the week of the 30th of October, next to the last day. It's a Monday till November 5th, next Sunday. Tomorrow's Halloween, and so we're going to pick up some dark spots in the night sky. Why not? And speaking of that, dark matter. We're going to take on that incredible mystery, and there's some understanding happening. A couple of possibilities. Science thinks it knows which one they want to go with. And you're not going to believe this. They come up with 6 things out in space that you might have thought might be there forever. They're younger than sharks. Sharks have been around longer than some of these things we're going to talk about. But first of all, our president, Jerry Wilson, forwards to us silly science cartoons, and we want to share it with you. I hope I got them nailed down because this was a good week. Got about 6 or 7. There's a Calvin and Hobbes in there. There's a pilot with a cane. Here we go. Now in charge. This is the one where that's a scene I think they clipped out of Harry Potter. I'm not sure. And
this is titled One Last Test Run.
That's right. And Chuck sent us a note saying, "Where's the black cat?"
Yeah.
Black cat's right up here, but you can't see it.
Disney last night ran one of those Hocus Pocus movies, and it's weird. All right. This one I don't remember getting. Couple of ghosts. No, they're angels. This is the
This
beyond,
was
right?
one I sent around a month or more ago, but no one could unscramble it. I finally figured out how to unscramble it.
Okay, they're obviously between the barn and the outhouse in the sky, and one goes to the other. You know, we keep the holy cow in the barn and the holy mackerel in the lake. I guess I don't have to tell you what we keep in there. The porta potty are us. Okay, got to do that in heaven too, I guess. All right, this one was my favorite. Everybody at the autopsy club was definitely excited because it was open mic night. Those
I
are the
like
Dutch,
that one. Yeah.
the Dutch masters. After this, they opened up a cadaver and then had a cigar. All right, this would be Calvin, or is this Hobbes?
Both. Calvin
both
is the
there. I'm
kid,
sorry,
Hobbes is the tiger.
I only see the tiger. There they are, splashing away, running amok in a puddle of water. Stay young, everybody. It's a great one. Kind of decides what scientists are all about. We're just curious and want to splash in the puddle. This pilot wins the Halloween award because he has a white-tipped cane making his way through the airport. You know, they're having stuff happen in the airports that are almost that bad for real. This one I like. This touched a nerve. Science is not about building a body of known facts, ladies and gentlemen. It's a method for asking awkward questions and subjecting them to a reality check, thus avoiding the human tendency to believe whatever makes us feel good. From Terry Pratchett. I don't feel so bad about my dumb questions now when I read that. Thank you. Keep that handy in case I ever make you guys shake your head. This would be the rocket landing accident featuring Flash Gordon. All he can do is apologize to the distraught alien for landing his rocket ship right on the poor extraterrestrial pet. See, we're going to have that. I assume that's a pet, or maybe it's a cow.
Looks like a cow thing.
It is a cow. It's not a dog. Oh, well, they can have a good barbecue. Glow in the dark trees. This is one that just stuns you. Glow in the dark. If we could have luminescent ocean waves at night, you've seen those. Now, is this true? Do we have trees that glow?
Yeah.
What's the deal? How's a Dutch designer working with scientists to create glow in the dark trees to replace street lights? Aha! They're made by crossing DNA from luminescent marine life with DNA of plants. Wow. Let's run that by city council.
Trouble is, you can't turn them off.
Yeah.
Well, in the daytime, it doesn't do a thing. It's at nighttime. You want them. This is the woman on the small iceberg, a little floating flow with a filled shopping cart and an inflationary groceries receipt, plus two nearby penguins, one of which says to the other, you know, personally, I'd say the cost of living is the least of this woman's worries, but what would I know, huh? How she got out there, we don't know. We don't care. There we go. Okay, that keeps us in a light mood. We lost Tom Whittemore. Did I introduce Tom? I did. He was there.
Yeah, you did.
Yes.
Okay, well, he'll be back, you know. He's probably taking those same dinky little pills my doctor just put me on. Diuretics are us. Fortunately, here we go. Let's go to one of the topics from the incredible list. The night sky. Got to start with a evening perusal with our scopes, gentlemen. You're going to have to enlarge it, I think.
This is pushing things a little bit. This is like actually it looks darker than in this picture than it actually probably is. But at 6 p.m. in the evening, this is your last glimpse of the major star of Buddhists down here, Arcturus. Let's see if I can bring that up.
There we go.
Arcturus. Yeah, there. Arcturus just before it sets. And this part of the sky, Arcturus is an interesting star. It is a red giant.
Wow, I'll say.
And it looks quite orange in the sky.
Yeah, well, orange giant compared to the sun in size.
Now, if our sun were in the middle of that big blob, where would Mercury and Venus be? Would they still be inside Arcturus, or?
Arcturus would reach out to about the orbit of Mercury.
Ah, got it.
Yeah.
You're right. I can tell that. Right?
So this is saying goodbye. I titled this section Exit Stage Left. This is a goodbye to the summer constellations.
And Jerry, that's zoomed up so that only a portion of Arcturus is showing. It doesn't show the comparison to the sun.
Oh, is it?
Yeah.
Oh,
When you zoomed in on the
What
other
now?
thing, it zoomed this one too. So we're still only seeing about half of it.
No, I'm seeing it all.
Oh, okay.
So am I. Do you have a full screen or just a partial screen?
Okay, now it's really zoomed.
yeah.
Yeah.
It is, but it still shows on my screen, it shows the sun and Arcturus.
Okay, I have to shrink my whole window here to see that. Okay,
Very
but it's
even.
doable. Never
So
mind.
Jerry, this is the time of the year you can say goodnight to Arcturus and the next day say good morning.
Yes.
I keep
Yeah.
looking this morning because we have really good horizons here to the northeast and northwest.
Yeah, you're up on a hill.
Yeah.
You manage to brag about that almost every week, but anyway.
Extremely dark skies here too, by the way, Jerry.
I know.
But normally it's a summertime phenomenon, a star we see.
Well,
No,
listen,
late in the fall,
Yeah.
you can say goodnight to Arcturus before it goes down to say good morning to it when it comes up ahead of the sun.
It's about the same height in the morning before the sun rises if you have a flat horizon out there, which here in Santa Barbara, we don't, but Tom
No.
is up on a hilltop, and so he gets it.
Well, no, we have hills in the northeast for the rise.
Yeah.
Okay. So I have to wait for it to come and come over the hill, but it's spectacular. And we
Okay.
often see Izar before we see Arcturus come up. So another star in the constellation.
Big as that sucker is, there are even bigger ones, aren't there?
Oh, yeah.
Oh, yes.
Yeah. That's the star with the famous story of opening up
The World's
the
Fair.
exhibition in Chicago. Yeah.
That's right.
Is it on its last legs like Betelgeuse?
Not
I don't-
really. Sort
I'm
of.
really ready to. They think Betelgeuse go any time, and it would be what 3 or 4 times bigger than this sucker.
Our sun will eventually get bigger than this
Wow.
because it'll go out past the orbit of Mercury, and it will go out past the orbit of Venus. Our sun will, and it will reach the area of the orbit of the Earth.
Yeah. And if you didn't mention this earlier, I had to run out because we're having some work done here, but Arcturus is the keeper of the bear. Right. Yeah.
Keeper of the bear. What does that mean?
Yeah, because the herdsman keeps the bears going around in circles.
Oh, in myth, yeah.
Yeah.
Oh, I didn't know that.
No, it really happens.
Well, they took to the World's Fair. They thought it was 40 light years away, and they
Right.
now know it's like 38 light years. But
That's right.
that's why
Yeah.
they used it at the 1923 World's Fair. When they in Paris, they used it in 1893.
Right.
Well,
Or
it's
actually, they didn't use it, but
it's also, you say in your notes, Jerry, 10 degrees high in the Boreas, the herdsman constellation.
hmm
Okay. So it's the
I
west
say Bootes.
Alpha Star. What does that mean, an Alpha Star?
The brightest.
Oh, the brightest in the
Oh.
constellation.
Also, sometimes Ron called a lucida. A lucid
Oh.
is the brightest star in a constellation.
What's the history of it? What does Arcturus mean? Where did it come from?
It means
Keeper of the
guardian
bear.
of the bear or
That's
keeper
what-
of the bear.
yeah.
Oh, is
And
that bear?
Boetes, the herdsman, has the hunting dogs, and they're
Right.
chasing the bears, and that's what keeps the sky rotating in the Greek story.
I thought
Okay.
bears were Ursus.
Trivia question:
Yes.
What are the names of the dogs?
Okay. got it.
Asterion and Chara?
That's right. Nailed it, Chuck. Nice job.
Well, its magnitude is minus 0.1. That means it's
Yeah.
pretty damn bright.
It's the brightest star in the northern hemisphere sky if you divide the sky by the projection of the Earth's equator.
What's roughly the magnitude of Venus? Minus what?
Minus
Four.
4 at brightest.
About 4.
4. Okay.
And it's starting to descend now. It's very subtle, but it's starting to come down in the sky.
I missed up. What is the magnitude of Arcturus again?
Minus 0.1.
Yeah, you can say
Oh.
0.
Yeah.
0. Okay.
Yeah, you can round up to 0.
When the stars get brighter, they become minus?
Yes.
Yes.
Oh man, that's
Yeah, the
sun's
sun minus 26.
Ron. The sun
otherwise they have
26.
positive numbers. The higher the positive number, the dimmer they are.
Yes.
That's right.
You
And
get to
each
about
step
8 or-
by one is 2.5 times different.
Right.
In brightness.
Oh,
and
And,
the whole
Ron-
world uses this.
Yeah.
This
A full
okay.
moon is about minus 13 and the sun is about minus 26. So there's 13 magnitudes between them. It's a log scale, right? So like Chuck said, it's 2.5, but now raised to the 13th power.
Wow.
oh, wow.
Well, I wonder if the web could see it like we just saw it there.
No.
No, I don't think so.
Don't think so? All right.
You don't want to look at bright hot things with the web.
Oh, is that right? They
It'll
can't
boil
do it?
off their cryogen.
Yeah, and you'll fry $1 billion worth of detectors.
No kidding.
Well, this is where the comet, a faint comet Lemon, is located near Alcade on Halloween tomorrow night.
Very low.
Yeah.
So,
Otherwise-
was that
so
named after Mount Lemmon, where they look for stuff like this down Tucson?
I don't know if that's named after them or not.
Okay.
I think it is.
Yeah, Mount Lemmon's is 10,000 feet up above Tucson.
or named after.
Anyway, if you go to Alcade, the comet tonight and tomorrow night is less than 1 degree from Alcade.
Wow.
It's a faint comet, but it's easy to find because of that guidepost star. It looks like a soft, fuzzy ball of light.
Okay.
With the atmospheric extinction we'll have, though, it'll be tough.
Right, and
Yeah.
also it'll be stuck in the glow of the sun, because that whole thing is arcing towards Arcturus. So
So it's inside the little target in the middle of the picture. That's where
Yes.
Yeah, the cursor here is that red bullseye, and that marks where the comet's position is. And this is the handle of the Big Dipper. And you can see Alcor and Mizar, which is a naked eye test of double star for your eyesight.
and there's the Whirlpool Galaxy down there.
Yeah,
Yeah,
51.
M51.
But if that target wasn't there, would we see anything? Is this supposed to be a picture of the comet?
No, this
No.
is a star chart. It's a planetarium software program, and it
So
was written probably 20 years or 30 years ago, so it doesn't include very recent comets. You can add them to this if you have their ephemeris.
Yeah,
You
how
think-
bright is it, Jerry? How bright is that comet?
Magnitude 9 right now.
Oh, okay. Small
Okay, but
scope.
Nobody's taken a picture of it. Does it have a tail or two?
Well, it's described here as a soft, fuzzy ball of light, so there's no obvious tail visually, but I'm sure someone will take a picture of it, and if they do, we'll dig it off the web somewhere.
Ah,
And if it stays clear this week, I'll probably try and take a picture of it.
Ooh, good luck.
Yeah, thanks.
How low is that, Jerry?
Oh, that's right. This is in the handle of the Big Dipper, which is well below Pole Star right now. So that's going to be problematic, too close to the horizon.
Yeah.
Just have to wait until late at night,
Yeah.
early morning to see the Big Dipper.
Yeah.
Yeah, late at
It's
night, it's
polar.
behind the mountains.
supposed to pass Earth or get closest next month. That would be November, right?
Yeah.
Which is right
Day
around-
after tomorrow.
Right. Right. So it's only one comet this week. It's 2 asteroids we're going to talk about, though, coming up.
Mhm.
One of them from the moon. Ooh.
That was interesting.
Well, we'll get to those in a second. First, we're going to talk about what are we going to talk about?
Cocoon Nebula.
Dark Nebula, the Barnard 168, sometimes called the Dark Cigar. It glows at, let's see what, it's it's in Cygnus near the Cocoon Nebula.
Huh.
And the Cocoon Nebula is listed up here. And this is Cygnus, the asterism for Cygnus with, where is it? Deneb right here.
Mhm.
So Deneb is a very bright star, famous North American nebula and Pelican Nebula, and up here, farther up, is the Cocoon Nebula. Now, the Cocoon Nebula looks like this, the red thing, and Barnard, the Dark Nebula, which is what this is about, aka the Cigar Nebula, is this dark thing that looks like a hole in the star pattern. But it's actually not. This is all solid stars, and this is a piece of gas and particles that is dense enough that it blocks all sunlight from.
So this is our Halloween topic. The dark side, like Horsehead
Yes,
Nebula
come
is
to
the
the
same thing.
The what?
It wouldn't the Horsehead Nebula and the Towers of
Yes,
Creation?
those are other examples of dark nebula.
Right.
There was a guy that focused on these things in the early 1900s, 1900 to 1920, and he put together a very beautiful book of photographs, very long photographs, 3 or 4 hours long. It was done on film to bring out the detail of these dark nebula. Now we have processing techniques that are and people that are so good, so well practiced at them, that they can not only bring out the darkness, show it, but they can bring out the detail in it. You can see structure in the dark.
Well, did we add the pink to the Cocoon?
Well, no, that's just, supposedly that's its natural light. It's heavily hydrogen alpha, so the 620 nanometer line of hydrogen. But
Would you
Jerry,
call that in?
visually, this would not be this would viewing it, you couldn't see this dark nebula, or could you?
if you had a big enough scope and a clear enough night, you would get a sense of it.
Okay.
But now is that
the nebula there is the pink nebula there is emission. It's actually emitting light. It's
Right.
fluorescing because there's a bright star in the middle there that's causing it to fluoresce. So that is really there.
But
Right.
are we looking at
the dark-
infrared?
No,
That's not infrared?
no.
No, this is how hydrogen alpha looks like to the human eye.
Wow.
This is a broad spectrum picture.
Yes. It's not a narrowband picture.
Okay.
And you can tell that because there's a lot of gold stars over in the right half. A lot of orange giants. And there's some blue stars. You wouldn't get that mix of color unless it was broadband.
Oh.
So you gentlemen could focus with your instruments and get this same picture, or would it require?
Yes, this is not a hard picture to get.
Really?
It
The,
requires a camera,
dark-
however. You wouldn't see it visually.
You what?
Don't you all have cameras on your units?
No,
No?
nope.
You use your cell phones. Put
I
it
use
up
my-
the lens.
I use my.
Oh,
oh,
In our telescope workshop, there's a lot of guys that talk about, imaging and stuff like this. And, they have either the CMOS cameras or CCDs, mostly CMOS now.
But the Cocoon does look like a cocoon. I guess it's just a separate, round, fuzzy bunch of gas, right? Or is there
I
a
think
star in the middle of it?
those names like Cocoon Nebula, those are popular names. They're not official names. They and it depends who looks at it and sees something that it reminds them of, and the name takes or it doesn't. I notice they change a lot over the years.
Well, the Lagoon Nebula is the same way. It kind of looks like a lagoon.
Yeah, yeah, maybe, but there's the what is it? The Eskimo Nebula is now the Lion Nebula.
Or the clown face nebula.
Or the clown
Clown face, yeah. I
The-
still call it the Eskimo. It's just
The Omega Nebula is now called the Swan Nebula, although I think it should be called the Two Nebula.
I told people that, Jerry, that you call it the Two Nebula, and they really like that.
I sometimes call it the Merganser Nebula because the neck isn't long enough for a swan.
Your cocoon is called IC 5146. What does IC mean? Is that a
Index
separate-
catalog.
index.
Okay, it's like a Messier
Yes.
for the
It's
NGC.
NGC-like objects that didn't get picked up, weren't bright enough to get in the NGC catalog.
Got it. Fascinating. And the cigar part, that's the dark part to the
That's
right.
the dark
right?
part here. And as Chuck pointed out, this is glowing because there's a star in there that's exciting it. There's no star in this, so it's not turned on by either reflected light or by emitted light. So it's just dark.
Well, if it's a cigar, it's a crook. You ever seen crooks?
Oh, yeah.
Yeah, they taste terrible.
We're not supposed to eat them.
Whoa, what do we have here? My God,
That's
that's
a lawn at midnight.
that carpet needs
This is called the Lockman Hole.
Oh,
It's in Ursa Major.
that's
This is a survey picture taken by the Herschel Space Observatory in infrared light. All the little dots in this picture are distant galaxies.
that was your second sending out of talking points.
Yeah,
That was
this
your
is the
identity.
update. Yeah.
Yeah.
The pattern of their collective light is what's known as the cosmic infrared background.
Wow.
These galaxies are 10 to 11 billion light years away, with the red ones being most distant. The Lockman Hole is an area of the sky in which minimal amounts of neutral hydrogen gas are observed from the perspective of Earth. That is, this is a region where there is no dark nebulas, so that we can see detail way far out. And it's a favorite place to look to study galaxies because there's no obscuring matter in our galaxy. So it's a lack of dust in the Milky Way. That's the hole. And so this is a picture taken in that region.
Would this be similar, if not the same thing as, let's say, the Borealis void? Is this a void we're looking at? Same thing?
Well, it's a void of gas, but the Borealis void is a void of galaxy clusters or galaxy presence. So it's a little different.
But it's still a big area that isn't blocked by any gas, any nebulas, right? You can
That's
see
what
through.
this is. Yes.
Yeah.
Jerry, is there any explanation why there's a lack of gases in this view from our perspective?
It's just like if you watch smoke boil off of a campfire. There are some places where there's dense smoke, and there's other places where there isn't much.
I see.
And so it's just like that. It's just a
Well,
random.
smoke follows beauty.
turbulence. What's that, Bruce?
I said smoke follows beauty.
Yeah.
That's an
Well,
old saying.
Both Hubble and Webb have had to find a little blank spot for their deep fields, right? That where
Yes.
there's nothing, no stars, nothing blocking to get that far out in space. Did
Yes.
they pick the same thing? Is the Webb deep field the same one that Hubble did? Only it's got far more galaxies.
I think it is, because I've seen comparisons of the two.
Right. They deliberately did that so you could see how much farther the
Yeah.
Webb could see.
Mhm.
These are all galaxies?
These
Yeah.
are all galaxies.
every one of those little dots.
And every one of those dots has billions of stars in them.
Well, that's why I hear the term 2 trillion when it comes to galaxies. Stars I could buy. We can't imagine trillions. That's 1,000 billions, and billions are 1,000 millions. My God.
Well, I can understand the red, the gold, and the dark, but the green, I don't get that.
Well, you got to. This is a color-coded false color image because it was taken infrared.
Okay, now I get it. Yeah, but the distance was just incredible. I thought you said it was something like to the 11th.
10 to 11 billion light years away.
10 to 11. 10 to 11. Okay.
10
Not
to
the 11th power,
not
but
10 to the.
I thought it was the 11th power. I was going,
no. Yeah.
That would be newsworthy.
Yeah, really.
All right. Time to join an asteroid. Which one is this one?
Vesta.
This is the Vesta, 4 Vesta. It's 8th magnitude right now, and it's in the news here because it's in opposition to the sun right now.
Magnitude 8.
It's a walnut.
Yeah. It's got these things, these puzzles, these streaks around it. Now, the thing may have squashed together like this, and this may be a bulge from that squashing when it was forming.
There's a really large crater that's kind of in the upper side, I believe, in this image. That's not quite visible in that dark area. And this
up
might
here?
be shock waves from that too,
Could
from that
be.
impact.
This thing probably rang, R-A-N-G, a lot after it got hit.
There are meteorites that have been found that seem to be pieces of Vesta. I can't remember the exact classification of them, but they're chemically distinct and they seem to match Vesta.
Okay.
Could those striations be caused by tumbling?
Tumbling?
Probably not.
It would have to tumble against something.
Okay.
So anyway, here is 4 Vesta, this red blob down here. Another asteroid, 5 Astrea is down here. Tomorrow night, the moon is very close to Vesta. And up here in the Crab Nebula is in Taurus. So this is a midnight picture on November 2.
I really like how your software shows the glow of the moon even washes out the.
Yeah. Tries to be realistic.
But now that Hawaiian named one, Kamoa, that's nowhere to be seen in these pictures, right?
No.
That's correct.
That's somewhere else.
This is an artist's rendering of it.
That's right.
I can't believe you could pronounce that, Ron. I couldn't. I tried. I couldn't do it.
You ought to
It
see
sounds pornographic.
Oumuamua helped me. Wait till you see that down.
So this asteroid, Kamualua.
Good luck.
I have trouble with Hawaiian names.
Well, you pronounce every letter in Hawaiian. So those
Right.
are silent ones.
So it's Kamualua.
Yeah.
Like the island that's off of Kauai, Niihau is pronounced Niihau. You pronounce both I's.
Okay, well, this thing is a Ferris wheel-sized rock chunk, which orbits about 9 million miles off Earth. And it's that distance from Earth every April. It goes around the sun with the Earth, but it's sort of around the Earth too. It's been known for a while, but someone decided that in a study they were doing, they decided that this thing had a suspicious orbit, and it may be traceable back to being a chunk of the moon that blew off when something hit it, or this was also created at the same time the moon was created from the big hit on the Earth by Theia. So they did a spectroscopic study of it, and it has the same surface spectra composition as the moon. So they're concluding that it is a chunk of the moon that somehow got free.
And it's supposed to be the size of a Ferris wheel.
Yeah.
And when
Now, Ferris wheels comes in a lot of sizes. You know, there's the big eye in London. And then there's the one that's over here at frequently at Earl Warren Showgrounds. So take your pick.
But supposedly moon was created, science says, by something, a body the size of Mars colliding with Earth, what, 3 billion years ago? That would mean another planet that went away, becoming
actually it's as you'll see later, it's 4.46 billion years ago.
Oh, so right about the time the solar system was created.
Well, it was later than the solar system. Solar system's about 5 billion, but it formed gradually. There's no one thing all of a sudden, bam, it's there.
Yeah, right. All that gas had to coalesce.
Yeah, it went through its own processes.
Okay, but that collision, something you've never seen a picture of, only artist renderings, two big bodies.
Well, we'd have to pass real close to it. It's 9 million miles from Earth this April, or every April, I guess. So
that's close.
Take pictures of it.
So that's 36 lunar distances. So it's, it's out there.
Yeah.
But there were
close enough for me, though.
Okay, here is this where we are right now?
This is the let's see, when is this?
Just had our full moon, you said.
This is the moon, 9 p.m. on October 31st, tomorrow night.
Ah.
So it's a waning gibbous moon. And this is a map again. It's not a photograph.
Hmm,
So
Black
there's
Cat
some nice pictures coming up. One of them up here, you see this bay in Mar Crisium or Mar Imbrium up here. And there was a really good photograph of that on Facebook a few days ago. Very nice picture. And as I clipped the
Colorful.
picture,
Now, did somebody amplify the color?
yeah, obviously, yes, I think they did. And it's an excellent picture. And I wanted to give them credit. He signed it JH, but I somehow couldn't get back to the thing to get the citation off of it. But there's a Facebook friend of mine who posts Astro pictures like this, Erica Rosas she's in Serbia, I think, or Herzegovina. She posts a lot of really nice photographs. They're not hers, but she is a good photographer. Too bad I didn't get his credits. But this is an absolutely astounding picture. It's beautiful.
Well, basically, gentlemen, could we see the same things in this picture that are in the photo behind Tim Crawford? Since we all see the same side of the moon all the time.
Well, the Terminator in his picture goes right down the middle of the moon. And so it goes down right there. And that's where you'll see the detail. If we look at the moon tomorrow night or tonight, you'll see a lot of detail along here. That picture is of stuff up here. So this would be challenging to get that kind of detail in it. That picture was taken just about a week ago or less than a week ago. And it shows when the Terminator is right about here. So it's just a crescent phase just before full moon was when he took the picture.
So have you noticed that as we get older, the damn cycles of the moon seem to be really speeding by? It seemed like we just had a full moon.
Life is like that.
It probably doesn't seem very long ago that you were 20 years old either.
I know. It just drives me nuts.
So anyway, the moon's age. Lunar dust samples from Apollo 17 were brought back years ago, and they've been studied. This shows how they were studied. This is a piece of a crystal, zircon crystal, from the moon sample, and it's been abraded with ion beams to come down to a point. And that was used to study, let's see, lunar crystal, right? A lunar zircon grain under a microscope. To study these zircon grains that were included in the moon dust. And the idea is that when Theia hit the moon, the rocks were basically melted, and any zircon crystals that were there before the moon was struck could not have survived on the surface when it was because the temperature was way too high. And so if they take the age of these zircon crystals, that will give an idea of when the moon finally cooled down and became the moon. So they're taking it as the age of the Earth or age of the moon. And they're looking at things that decay that are in the regions of these crystals in the rocks. And they're looking at uranium as it turns to lead over time by radioactive decay. And this is called an isotope study. And it's a technique used for dating Chuck's meteorite and the sample of the moon. And it comes, the isotope here indicates that it's 4.46 billion years old. And they claim that is therefore the moon's minimum age.
Wow.
Well, I thought that's the age of the Earth.
Earth's a little bit older than that.
Yeah.
Not much.
Not much.
Well, as long as you're on these two pictures, I'm trying to decide the names I'm looking at. 200 nanometers, right?
Yes.
What's the U-shaped thing? Is that a gamma? Is that called gamma?
That's a micro.
Micrometer.
Oh, yeah, yeah, this Greek
A
letter,
million.
yeah. Micron, this is 10 microns.
Which is
Uh,
smaller than nanometers.
No.
No, nanometers are smaller.
Oh, they're smaller. Okay.
A human hair is about 100 to 300 microns.
Microns. Wow.
If this were if this were 1,000 nanometers, it would be 1 micron.
So there's no disagreement, metric versus the Western style. We all agree around the world on this way of
Yeah, this is metric.
This is metric.
Yeah.
But
You know, a meter is 39.37 inches, and a micrometer is 39.37 billionths of an inch.
Millions.
Millions, that's what I said. MILLIO, that word.
But my point is, when we're down to this small, everybody agrees on the same numbers. We say inches, they say centimeters, right?
Now,
We say
science
miles.
really does use its own version of systems, and usually the metric.
I wish we could get
Big
together.
differences for metric is you use the MKS system or the CGS system. One is metric, MKS is meters, kilograms, seconds, and the CGS is centimeters, grams, seconds. The constants in the equations are slightly different.
A rough rule of thumb is you can convert micrometers to microinches by multiplying by 0.4.
You could, but we seldom report things in inches, imperial
Well,
system.
it depends.
That
More,
meters times 0.4 wouldn't give you inches. That might give you feet.
39.37. So 39.37 inches is 1 meter.
Yeah, times 0.4.
Right.
But
Now, the
metric,
only
more like a
problem in
foot.
the US that you get a problem with the metric versus the imperial is in the hardware store.
oh yeah.
Because at that scale, for example, optical in the US, a standard optical screw is a 1/4-20 screw. Well, all your cameras have that screw in the bottom of them. All of our telescope plates from Los Mandy and everybody else has 1/4-20 things drilled in them. But you can also get the metric. In Europe, they use metric for that scale of things. But in scientific laboratories where I was, we all use metric systems and Kelvin temperatures.
Isn't our whole number system metric based on 10, the number of fingers we have? And
Yeah.
that makes sense to me. We should be on
It's an
metric.
easier system to work around in.
Yeah.
It loses the charm of thatched houses and the imperial system.
Or
But-
mud bricks and base 60.
Yeah.
Okay. Fascinating
Okay.
stuff.
In fact, the Maya used base 20. And so that's how you could tell they lived in a tropical climate, because they were counting on their toes too.
Toes and
Well, then the men would have a 21 base number system.
hello. It's like the surfers that go out surfing naked and they hang 11. Never mind. Shut up.
Okay, we've taken a turn to the dark side here.
Yes, we have. I'm sure we
Twice now.
have. Okay. Oh, here we go. Well, Einstein rings is going to lead to dark matter, and we're going to actually take that topic on, Mr.
Yes,
President,
I
gentlemen.
had a shorter version of this that just appeared in our newsletter. But
Looks like a cartoon, a smiley face in the sky.
yeah, but it's not photoshopped.
No?
Actually, it probably was photoshopped to process it, but it's not created by Photoshop.
Wow.
So there's a lot of speculation about what dark matter is, even if it is. But given that it is, then what is it? And two leading contenders have been WIMPs, which is an acronym that stands for weakly interacting massive particles, and an extremely lightweight particle called an axion. Both of these particles, WIMPs and axions, are hypothetical particles. That is, they've never been seen, they've never been identified, they've never been proven to exist, but they've been theoretically prophesied, you might say, or indicated that they should be there they patch several holes in quantum mechanics standard model. And if they're there, it makes certain parities and systems preserved in a nice aesthetic manner. So, but the key difference between WIMPs and axions is that WIMPs are big and heavy by comparison. And so they act primarily particle-like. They have wave nature. Every particle, because of particle wave duality, has both particle and wave nature. A basketball is, in a sense, a particle, although it's many particles, and it has a matter wavelength to it. But you don't see that acting like a wave on the basketball court. It's primarily particle nature. WIMPs are primarily particle-like in nature, not to the extent a basketball is. And axions are primarily wave nature. So some theorists calculated what this Einstein ring would look like through lensing, gravitational lensing, if the lens gravity was due to the visible matter in a galaxy and all of its dark matter. So the dark matter can be mapped to some extent, but using that same mapping of dark matter and visible matter, they calculated what the resulting Einstein ring would look like if it was an axion or if it was a WIMP. And the WIMP model did not look anything like the actual Einstein ring they were seeing, but the axion matched it very well. So that doesn't prove that axions are dark matter, but it does say that whatever the dark matter is most likely going to be like the axion is prophesied to be. It's mostly going to exhibit its wave particle and not its particleness. Its wave nature and not its particle nature. Questions?
Lightweight versus heavy. Why would one be heavy and the other lightweight? What's the difference? They're both invisible and they add to.
Well, no, they're not invisible so much as they're not, they don't know that they exist. By the way, the thing that makes them a dark matter candidate in the description of them that theorists come up with is that they have no charge, they're neutral. And that's the key thing that makes it a dark matter candidate, because dark matter, whatever it is, it has no electric charge. But the primary interaction between light and matter is through electric charge.
But light supposedly is both. Quantum has given us that it's
Well, it's the duality. It can be either. It's all depends
so,
on what works.
Why can't we have this?
Everything can be either and is either.
Yeah,
But
Ron,
at the same time.
Ron, as Jerry was pointing out, even a basketball is dual. It's a particle and it's a wavelength. So, photons are just that, but they're extremely, in this case, light, like axions, lightweight, low mass.
I didn't hear him say a basketball was like a wave. I heard him say the opposite.
Puns just pop out here.
No, he said most of the behavior you would see in a basketball would be particle-like, but it does have a wave function.
How would that? You'd need a lot of basketballs going at the same time, but there's only one in a game anyway.
Well, it really makes sense in quantum mechanics, which is a description of the subatomic world, to talk about a single particle. A basketball is really not a single particle. It's a collection of 10 to the 23 or 10 to the 24 particles. But every particle does have a wave nature. It's just that when you play basketball, you're playing with the particle nature of the basketball.
Well, can I bring up something that seems very, very childish and fundamental, but it came to me that there's matter around us right now that we cannot see, but we know it's there. The wind, the air, water.
Yeah.
If we get into water, we can't see it either. You can see all the way through it. If you took a little piece of the air or a little piece of the water, could you see it under a microscope? Or is it still invisible to us?
No, if you had an electron microscope, you can see atoms and molecules that you wouldn't see with your eye.
But get a whole bunch of them and you can't see anything? They don't.
Well, Ron, it depends how they interact with light.
But I mean, dark matter seems a lot like our air.
In that analogy, it is analogous, but when you have air, you'll go outside, and if the air is moving by you at 100 miles an hour, it'll blow you over. So there's no doubt that it's there, even though you can't see it.
Right.
But you can see all the particles it picks up in it. But in a dark matter, you can't see the dark matter, but you can tell it's there because things start to orbit it. So there's got to be something there.
And Ron, air interacts with light. That's why you see a green flash when the sun is setting, through an inversion.
Right. And it's what destroys our seeing in our telescopes.
Yeah, wiggling.
Well, okay, perhaps.
Hey, Jerry, do you mind just for a second if I mention something?
Go ahead.
Tom Totten was trying to listen to the program, and his phone, he couldn't get the sound. And I tried to use the chat box. I don't think he can see it. But Tom, if you're out there, could you just send me a text to see if you are getting the sound in your truck now? I'd appreciate it. Thank you.
In his truck?
Yeah, he had to go to his truck and use the Bluetooth out there.
He's got a hybrid. I wonder if that's part of it.
It's not a hybrid. It's full electric.
Oh, it is. I didn't realize. I thought it was a hybrid.
No, he has an electric Ford F-150. Beautiful truck.
Got it.
Lightning.
Okay.
So anyway, this is when a new instrument goes up, people write to the office that controls the instrument, say the Carnegie Institute, and they ask for time on the telescope. And so this is the proposal submission numbers, and this is time before the event, time left until the deadline when a decision is made who gets what time. And it's rated by a panel of peers who decide how your argument about how this fits in, why it's important, what we're going to get out of it, and why you need to do this. And they pick it for what the next project is. Scientists are clamoring for a time on all sorts of these things. The red ones here are the JWST time, and they do this in cycles. They go through a period where they solicit the proposals, and then they decide this is the number of proposals for JWST that was submitted in the first cycle. In the second cycle, you can see it's bumped way up. And in the third cycle, it's gone way up. These other cycles, all these dark ones, these are Hubble telescope times that are used. So the JWST time is way more popular than the Hubble instrument is. And the Hubble has been deciding on times through 31 cycles so far. So that's a tough line to get in. That's where people's grant requests goes to get the telescope time.
It would have been interesting to see an early Hubble cycle if that was way up there too.
Yeah, it would. This was just something I happened upon. Good picture.
You spent a lot of time researching this stuff.
Neither of those telescopes can do anything at any one time that's around near the sun. It's got to be facing away from the sun.
No, Hubble doesn't look at the sun, but it's not as critical that it hide from the sun as effectively as the Webb is. The James Webb has got a reservoir of helium, liquid helium. It boils off at 4.3 degrees Kelvin. That's damn cold if you've ever experienced that.
Has the Webb got an unlimited supply of rocket fuel that aligns it with what it wants to look at?
That's not the rocket fuel. It lines with
reaction wheels.
Thank you. Reaction wheels.
Reaction wheels? Move it?
Yeah.
Actually turn it?
Yeah, they're little things.
They're gyroscopes. And if you put a torque on a gyroscope, it'll apply a torque that's 90 degrees different.
Oh,
you can use it to move stuff around.
Yeah.
But it's got solar panels, right? The power.
Yeah. No, it doesn't. It has a reactor.
Well, no, the James Webb has solar panels.
Okay.
The reactors are on the rovers.
But something mechanical turns it, not little rocket jets.
That's correct, because you don't want to contaminate the mirror.
The trouble with the rocket jets is the exhaust condenses on the surface of the mirror.
Well, the only thing missing from your chart there, Jerry, was the price.
Oh
How
yeah,
much-
that's another issue. You have to once you get time on a reservation on the thing, then you can go say, I need this amount of money.
Yeah. Well, go to
But
LCO
anyway,
then. Is
this was another
Io?
chance thing I saw on the internet. It's the recent photograph of Io, Jupiter's volcanic moon, and it was taken from the Juno spacecraft. It is an incredibly sharp picture.
Boy, it sure is.
I don't see any volcanoes erupting.
Not any active ones spewing off into space, but of course the whole surface of the moon is formed by all the constant lava flows and eruptions.
Ah,
And then we have the famous things that are older than sharks.
okay. Well, let's go down all 6 of them.
Younger than sharks, right?
Yeah,
Younger than
as old
sharks.
as sharks are. Sharks
Yes,
came into being before Saturn's rings, 100 million years ago.
things younger than sharks.
Wow.
So there were sharks on Earth when Saturn's rings formed 100 million years ago.
Okay.
And Saturn's rings are considered a transient phenomena. That is, that are not permanent or stable. The Pleiades cluster formed 75 to 150 million years ago.
Well, that's just the configuration, right? The stars might have existed before.
No, that's when the stars came into existence, because at first it was a cloud. Then the
Oh,
stars condensed out of the cloud.
It's not like the stars moved together to form the Pleiades. The stars formed in a configuration probably even more condensed than the Pleiades, and they're gradually moving apart.
and yet our sun is 5 billion years old, and these little babies are only 75 to 150 million years.
Yep,
Those are babies.
a lot of exoplanets.
Okay. Did you miss the galactic orbit of the sun? Third
Did
one?
what?
The one above it, exoplanets, one galactic orbit of the sun. I don't remember you saying that. In other words, going all the way around the galaxy.
Yeah.
Oh yeah, we did that last week.
No, but you didn't mention it. It's number 3 in your list, and you didn't mention it here.
You missed it.
Okay. So, yeah, that's what you're saying.
Yeah.
You just got to start screaming, "Hey, you missed one!"
Yeah.
225
One galactic
million.
orbit of the sun is 200 to 225 million years. So sharks have actually done it twice.
Okay. And dinosaurs predated that too, I guess.
The last week or the time before, we said that the last time Earth was on the other side of the galaxy, there were dinosaurs on Earth.
Whoa. And a lot of exoplanets.
A lot of exoplanets are that age, are younger.
Okay.
Light travel time across the Buddha's void, the largest known void between galaxies, 350 million light year diameter.
Sharks were here before that, huh? Wow.
Yep. And fascinatingly, the North Star Polaris is estimated at 70 million years old.
No, that doesn't mean it moved into its position since the sharks came. It was created just like the others in the Pleiades.
Yeah,
Right.
it came into existence.
Well, I have a new respect for a great white, but I'm still going to get out of the water.
Yeah.
I got to tell you, I learned so much from you guys. I just
I'm
wish I
not going to
could.
try and outlast them, Ron.
Well, we all saw the movie. Do you know they have a play on Broadway about making the movie Jaws?
Really?
Yeah, and it was written by the guy that stars, and it happened to be Robert Shaw's son. Robert Shaw got eaten by a great white. He was Quint. in the
Right.
movie. His boy looks just like him.
Huh.
Well, Friday night we have I won't forget the professor's name. He's from Cal Poly, I think.
Dr. Povich.
Povich.
Pomona.
Yeah, Matthew Povich. You're going to talk to us about star formation. You're all invited, folks, to come join us. Get there early enough. Whether you're a member or not, you can see our little star party show in the planetarium, or is that just members only?
Planetarium show at 7:00 is open to anybody who comes.
Someday Tom Whittemore will be running that program. I'm just confident of it, gentlemen.
Yeah, they're looking
Take
for
care of
volunteers.
yourselves and your wives and enjoy the full moon and dark nights. Not a lot of light. We'll see you next Monday morning, though, and And I guess we won't have a planning meeting, which is fine with me.
Yeah.
Take care, everybody. That's it for the Santa Barbara Astro Hour, number
Bye.
200 and something. My God.